Hey, this lesson is a review on the important information about cross sections. Of course, you want to make sure you have your first name and your last name and the date, as well as your class period and the title of the assignment, which is the cross section review. To review what a cross section is made when a two-dimensional plane intersects a three-dimensional figure. The best way to think about it is like you're slicing a loaf of bread. And your three-dimensional figure, whatever shape that's in, that's your loaf of bread. And your two-dimensional plane is your knife. And the cross-section is the shape of the piece of bread that you're cutting off. There are different types of cross-sections and different types of figures that we're going to be reviewing. The first type is going to be for prisms, which, to briefly review, are your shapes that have the same base and the same top and have rectangles for all of the side faces. So the first type of cross-section that we're going to look at for prisms are parallel to the base. This is where you would take your knife and slice it through your bread parallel to the bottom of the loaf. The next kind is we're going to look at perpendicular to the base, and this is where you would take your knife and slice it through the loaf of bread from top to bottom, 90 degrees. And then the third we're going to look at is where it's not parallel or perpendicular to the base. So it's going through at some sort of an angle. We're also going to be looking at cross sections for pyramids and cones. We're going to look at cross sections that are parallel to the base, cross sections that are perpendicular to the base through the vertex. And when we get to this section, I will review what the vertex is for those of you who don't remember. And we're also going to be looking at perpendicular to the base, not through the vertex, so sort of off center, but still 90 degrees to the base. And finally, we're going to be looking at cross sections that are made by slicing not parallel or perpendicular to the base. There are some things that are always true when dealing with cross sections. The first thing that is always true is that any cross section that is made parallel to the base is the same shape as the base itself. So if the base is a square, then a parallel cross section to the base results in a square. If it's a triangle, a parallel cross section to the base results in a triangle. Pentagon becomes a pentagon. Hexagon, hexagon. It's the same shape as the base. Something else that's true about cross sections is a cross section of a prism made perpendicular to the base is always a rectangle because it's always the shape of the face, and all of the faces in a prism are rectangles, regardless of the base. And finally, a cross section of a pyramid or a cone perpendicular to the base through the vertex always results in a triangle. So the first thing that we're going to look at is visual examples of cross sections. And we're going to start with our prisms. Here are the 4 different examples of prisms that we're going to be looking at. The first one is our rectangular prism or our square prism, which we would call a cube. The base is a rectangle or a square. The second one is a hexagonal, which has 6 sides, a hexagonal prism, where the base is a hexagon. The third is a triangular prism, where the base and the top are triangles. And the fourth one is a pentagonal prism, where the base and the tops are pentagons. This is just to show you the consistency of the cross sections, that no matter what the base is or what direction you're cutting, that these rules apply for every prism. So the first thing we're going to look at is a cross section made parallel to the base for these prisms. The first prism we're going to look at is the rectangular prism. You can see the shaded area is my cross section that's been made parallel to the base. It's the exact same angle as the base of the prism. Therefore, it is the exact same shape as the base of the prism, which in this case is a rectangle. For a hexagonal prism, again, you can see the shaded area here is the cross section that I have sliced through my piece of bread parallel to the base. You can see it's the same angle as the base, and therefore it is the same shape as the base. In a triangular prism, the same rule applies. A cross-section parallel to the base is the same shape as the base. And of course, it's true for a pentagonal prism as well. You can see the shaded section again is the parallel slice, and the cross-section resulting is the same shape as the base of the prism. The next thing we're going to look at are slices perpendicular to the base. Remember, perpendicular means 90 degrees. So this is where I would take my knife and I would slice it through my loaf of bread, shaped like whatever these prisms are, and it would be 90 degrees parallel with the 90 degrees perpendicular with the base of the prism. The first one I'm going to look at is, again, the rectangular prism. Here you can see my cross-section has gone from top to bottom. You can see that it makes 90 degrees with the base of the prism. So instead of being parallel to the base, it's now perpendicular. It results in a rectangle. With a hexagonal prism, you can see my slice perpendicular to the base here. It goes straight through, up and down. And what you notice here is the points of the intersection of the plane and the figure. It goes through here and here. So it slices straight down, and therefore that results in my rectangle. Same thing with the triangular prism. My slice starts here, goes straight down. So from here to here and here to here, therefore resulting in a rectangle. And finally, the pentagonal prism. Again, my slice starts here. I go straight down, perpendicular to the base, and it results in a rectangle. There you can see the proof that any prism sliced perpendicular to its base creates a cross-section of a rectangle. Now we're going to look at the next type of slice, which is still the prisms, but we're going to look at a slice that's not parallel or perpendicular to a base. So this is on an angle. It's not parallel, it's not 90 degrees. Here you can see the slice has gone diagonally through the prism. And again, you want to think about where the slice starts and envision the slice going all the way through. Well, here it creates a rectangle for the rectangular prism. For the hexagon, you can see the slice going through at a diagonal, and this is where it would slice. It would slice here to here to here and to here. So what results is this sort of stretched out hexagon. Same thing with a triangular prism. On an angle, you can see the slice coming through. It would start up here, it would go down this direction, it would come out here. So it produces this sort of elongated or stretched out triangle. And finally, for the pentagon and the pentagonal prism, again, slicing at an angle, so you have short pieces up here, you've got a long slice on these two sides, and then it comes out at the end. And so it creates this sort of stretched out pentagon. So the rule here is, if you are slicing a prism not parallel and not perpendicular to the base, you're going to create an elongated or a stretched out version of the base. Now let's move on to pyramids. And remember, a pyramid consists of a base shape. Any shape can be a quadrilateral, triangle, any polygon. And all of the faces meet at a certain point, which is what we call the vertex. So here I have an example of a pyramid. This right here is the vertex. This square or rectangle is the base. So the first thing we're going to look at is a cut parallel to the base. And remember, anything parallel to the base is going to be the same shape as the base, no matter what shape you're talking about. So here you can see I've sliced my bread that's shaped like a pyramid through right here, parallel to the base, and it creates the same shape as the base. Now, depending on where I slice it, it's a different size, but it's the same shape. Same thing with my triangular pyramid. I cut straight through here with my knife, and it creates the same shape as the base. Again, not the same size because I've cut further up, but the same shape. And finally, I have a hexagonal pyramid to prove that slicing through gives me the same shape as the base if it's parallel, even though it might be a different size. Now I'm also going to look at a slice perpendicular to the base, which again, 90 degrees, perpendicular to the base through the vertex. So for my square pyramid, you can see my vertex here, and you can imagine that my knife has started here and gone straight down. So it started here and sliced equally at the same time on both sides here, and then it ended when it got to the base. Well, you can see that that slice is in fact a triangle. On my triangular pyramid, same thing. I start at my vertex, I go straight down the center, and I slice here, here, and then it stops when I get to my base, and that creates a triangle. And then with my hexagonal pyramid, same thing. I start at my vertex, my knife sliced down through here, it sliced through here, and then stopped at the base, and that produced a triangle. So this proves that any slice or cross section perpendicular to the base through the vertex of a pyramid produces a triangle. Now we're going to look at slices in pyramids, cross sections in pyramids, not parallel or perpendicular. So here is the angle slicing. So here is my square or rectangular pyramid. And you can see here that my knife has gone through at a diagonal. It started here and it's come out here. It's on this angle. Well, it slices up here and then it goes through on the sides here and then it comes out about halfway down. Well, what shape has a small top, the same length sides, and a larger bottom? It's a trapezoid. With my triangular pyramid, it starts here. Again, it's on this sort of angular path here, this slanted path. It cuts here, it goes through, and comes out, obviously creating a triangle. And then with my hexagonal pyramid, does the same thing. Starts up here, and it's sliced through on this sort of angular trajectory. It has a tiny little slice up here, and then it has the longer slices here, really long slices along this part because it's traveling at an angle, and then a wider slice at the bottom than we have at the top. So again, still the same shape as the base, but a little distorted. So again, just similar to the slicing of the pyramids at an angle, it produces a similar shape to the base, but with elongated sides. So you can see the sides here are elongated, so still a hexagon. The sides here are elongated, but still a triangle. The sides here are elongated, still a quadrilateral, but a different quadrilateral than the base because the sides of quadrilaterals change the shape's names. And the last one with pyramids that we're going to look at are perpendicular to the base, but not through the vertex, so sort of off center. So here I have sliced through, but I've started off center. I didn't start at the vertex this time. I started off center and I sliced straight down with my knife, and it started here and then it cut as I went down and then it stopped at the base. Well, this also produces a trapezoid. With my triangular pyramid, excuse me, same thing. I started cutting here, but I went straight down. It's still perpendicular, it's 90 degrees there. But I sliced here, and as I sliced, it took the sides as they were fanning out, and then stopped here at the base. So this also produces a trapezoid, you can see, as it goes down there and there. And then finally through my hexagonal pyramid, again, I start off center, I don't start at the vertex. I come down the side a little bit further, down this face, and I start cutting right here, and I drop my knife straight through there, so it cuts here, and then as it slides, it cuts these two sides, and then it stops at the base, which also produces a trapezoid. So you can see the rule here, that cutting a pyramid perpendicular to the base, but not through the vertex, always results in a trapezoid. The last thing we're going to look at is cones. These aren't quite as long because there's really only one kind of cone, and that's a pyramid with a circular base. So the first thing we're going to look at is slicing cross sections parallel to the base. Well, it's true that any cross-section parallel to the base produces the same shape as the base. Well, in a cone, the base is a circle. So if I slice this parallel to the base, it creates a circle. Just like with pyramids, how far up or far down I slice this determines the size of the circle, but because it is a cone, if I slice it parallel to the base, it is a circle. The next kind we're going to look at is slicing perpendicular to the base through the vertex, which the vertex is the same on a cone as it is in a pyramid. So I would slice starting right here at the center in the cone at the vertex, slice down, and of course the slice would have the sides of the cone. Because it's a two-dimensional figure, there's no curve. And so I get the straight side here, and it stops at the base. So it produces a triangle. Just like a pyramid, any pyramid you slice through the vertex perpendicular to the base creates a triangle. Then we have perpendicular to the base, not through the vertex. So this is where I would slice it on an still perpendicular, so not an angle. This is still 90 degrees to the base. But again, this is sort of the off center, that I come down the slope here or down the side a little further instead of starting at the vertex. And then I slice my knife through here. Well, you can see this produces this nice little curve. And so I get a semicircle. The size of the semicircle would depend how far up or how far down I started slicing. Obviously, if I sliced further up, I'd have a much steeper or elongated semicircle. And if I sliced further down, it would be a little shorter and fatter. And then the last one we're going to look at is cross sections made by slicing not parallel or perpendicular to the base. So this is the one that goes through at an angle or some sort of diagonal. So as I slice through, just like with the prisms and just like with the pyramids, it produces this sort of elongated shape because where you start up here and where you travel down to here, it has longer sides, if you will. Now, obviously, it's circular, so there aren't real sides, but it's an elongated version of the base, which in this case, we either call, the official word is an ellipse, or most of you will know it as an oval. All right, thank you very much for watching. Now you should start in on your lessons and your practice.